Hello everyone, welcome back to our channel. Let's discuss the next reaction, that is fourth reaction, Algar Flynn Oyamada reaction. Before going to discuss about this particular reaction, let us see some terminology. Here we have a term called as flavonoids. We all know that flavonoids are very important compounds. Nowadays we all are used in our diet. If you see the source of the flavonoids, the main source is the what? Plants. Generally, we will observe these flavonoids in blackberries, soybeans, red cabbage, onions, dark chocolate and citrus fruits. These are some of the common sources nowadays which we are observing for the flavonoids. Generally, these compounds are polyphenolic compounds. It means that what? The phenol rings are present in all kinds of the flavonoid materials. The general carbon skeleton involved in the flavonoids will be like this. If you observe this particular skeleton, we are having 15 carbon atoms. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The basic moiety or the basic skeleton of a flavonoid moiety containing how many carbon atoms? 15 carbon atoms. That's why the skeleton is C15 carbon skeleton. If you see that C15 carbon skeleton, that is arranged in 3 different rings. One phenyl ring, second phenyl ring, this one is what? One heterocyclic 6-membered ring. So, the basic skeleton of the flavonoid moiety containing 15 carbon atoms, all the 15 carbon atoms are arranged in the form of 3 rings. Out of the 3 rings, 2 rings are phenyl rings, one is the 6-membered heterocyclic ring. Clear? Then, if you see the classification, we are having 6 types of flavonoids. The first category of flavonoids are what? Flavonols, flavones, flavone-3-ols, flavonones, isoflavones and anthocyanidins. These are the different categories of flavonoids which we are observing nowadays. Recently, the research work confirming that if we take rich amount of these kind of flavonoids containing foods, it can reduce the risk of cardiovascular disease, diabetes and some of the cancers also. See how these compounds are important in our daily life. Everyone is taking in the form of some material. It may be a fruit or it may be any kind of item which we are taking nowadays. From this particular point, we observe that these materials are very important for us. That's why there is a need to synthesize these kind of flavonoids. For that purpose, we are having a reaction called Algar Flynn Oyamada reaction. Let us see the statement of this particular reaction. The statement of this particular reaction is if you see the statement tells us oxidative cyclization of chalcones into flavonols. The starting materials involved in this particular reaction is that what? Chalcones. The products are flavonols. The flavonols are one of the main category of flavonoids. By using this particular reaction, we are going to synthesize flavonols. But the starting materials are what? Chalcones. Simply, how can we represent this particular reaction? Conversion of chalcones into corresponding flavonols. Here we are taking the reagent called H2O2 in presence of base. Hydrogen peroxide in presence of base. It can also be called as alkaline H2O2. Alkaline H2O2. The chalcones are easily synthesized by the combination of aromatic aldehydes and ketones. Already we discussed in aldol condensation, right? Let us see the general equation of this particular transformation. General equation. This is one chalcone. Say this one. Alpha beta unsaturated ketone. With respect to keto group, this is alpha position and this one is the beta position. That's why this compound is commonly called as chalcone. The chalcone is converted into the corresponding flavonol. Here we are having the reagent called as alkaline H2O2. It can be represented in this way. In this particular transformation, initially we are getting one intermediate compound. The intermediate compound will be like this. C double bond O, OH, this kind of intermediate is forming initially. This one is further subjected to elimination of H2O. It can produce this kind of compound. If this intermediate subjected to oxidation, it can produce this kind of compound. OH double bond, this kind of compound. If you see this one, the basic moiety or the basic skeleton of flavonoid is what? 3 rings. 2 are the phenyl rings. 1 is the heterocyclic ring. Phenyl ring. This is heterocyclic ring. It is containing what? OH group. We all know that if the organic compounds are having this kind of group, then the compound name is ending with what? OL, ol. That's why this compound is commonly called as flavonol. Flavonol. It can be easily synthesized by using this particular reaction. Next, mechanism portion. Let's see how this transformation takes place from the chalcone to flavonol. Chalcone is the starting material. The starting material is initially reacted with what? Alkaline H2O2. We all know that if you have the olefin, if the olefin is converted into the corresponding epoxide, we need to use a reagent called as peroxide. The conversion of olefin into the corresponding epoxide. These type of compounds are commonly called as what? Epoxides. Epoxides can be easily synthesized from olefins by using the peroxide. Similar kind of concept is going to applicable on this particular chalcone. If you see this one, here we are having a carbon-carbon pi bond or not. Initially what happens, the carbon-carbon pi bond is subjected to oxidation by using the peroxide. What will be the product? Epoxide. How can we write the product? Benzene ring, OH, C double bond O. The pi bond is converted into epoxide. Now this one is connected to one phenyl ring. This is the first step, is the conversion of the carbon-carbon pi bond into epoxide from this particular transformation, right? In this case what happens, along with the peroxide we are using base or not? Already we know that the use of base is what? The removal of acidic proton. If you see this particular moiety, here we are having a phenol ring or not? We all know that. Comparing with the phenol, phenoxide ion is more stable in nature. Why? Because the O minus is involving in the delocalization with all the 3 pi bonds which are present in the benzene ring. That's why phenoxide ion is highly stable. Okay. The similar kind of situation is going to happen in this particular reactant. Here we have used the base. The base is going to remove the proton from this particular OH group. Thereby what happens? This OH will be converted into O minus along with the formation of this epoxide. I think this concept is clear to everyone. Let's proceed further. With respect to this pi bond, this is alpha position, this one is the beta position. The negative charge can approach either beta carbon or it may approach the alpha carbon. It means that what? We are going to have 2 pathways for the formation of the products. Let us see the first pathway, that is what? Pathway 1. The pathway 1 is the what? Attacking of negative charge on the oxygen atom to the beta carbon. What will happen? Here the carbon valency is going to be increased. That's why these single bonding electrons move towards what? Oxygen atom or not? The oxygen will attain negative charge. Thereby we will come up with this kind of compound. Oxygen, C double bond O, this one is oxygen minus. Already we know that we have removed proton from this particular OH group or not. It means in the solution we are having H plus ions. Those H plus ions move towards this O minus. Then the O minus and H plus going to give OH. This is the intermediate in the particular transformation. Now what happens? Oxidation phenomena takes place. Oxidation means what? The addition of oxygen or removal of hydrogen. Let us see. Here we have one hydrogen, here second hydrogen. These 2 hydrogens removed in the form of H2. That is commonly called as what? Oxidation. Thereby what happens? if you remove these two protons, or we can say these two hydrogens, you will come up with a pi bond or not. Finally, the compound will be oxygen double bond OH double bond and phenol ring. This is the flavonol. In this way, we can easily transform the chalcones into the corresponding flavonols. Okay, let's see the applications. This transformation is saying that the reactant molecules will be chalcones. The conversion of chalcones into what? Flavonols. But in the competitive examination, you will not directly get this kind of transformation. See the first example. OH C double bond OCH3 hydroxy substituted aromatic ketone. If this one is treated with CHO NaOH in ethanol followed by H2O2 in NaOH. Identify the product. These kind of transformations you will get in the competitive examinations. If you clearly observe the situation, what is the first reactant? This is an aromatic ketone. Aromatic ketone is having what? Alpha CH function. The first reagent is what? Benzaldehyde. It is also aromatic aldehyde. This aromatic aldehyde does not containing any kind of alpha CH protons. Then we can have a reaction between this aromatic ketone and this aldehyde. Already we know that Claisen-Schmidt condensation. According to Claisen-Schmidt condensation, the combination of aromatic aldehyde with the ketone having alpha CH function produces chalcone. So the first step is the what? Formation of the chalcone. Here you will get chalcone. OH C double bond O in this particular transformation, initially we will get beta hydroxy ketone. The beta hydroxy ketone is subjected to dehydration, removal of water molecule to form a pi bond. Now this is the what? Chalcone. So this transformation is the example of Claisen-Schmidt condensation. Claisen-Schmidt condensation produces the chalcone. Now the chalcone is going to treated with H2O2 in NaOH, alkaline peroxide. This can produce the desired compound double bond OH flavonol. So this transformation is commonly called as AFY reaction. So in this particular transformation, we are observing two chemical reactions. First one is Claisen-Schmidt reaction followed by Algar Flynn Oyamada reaction. This is the first application of this particular thing. Let's see the second application. In the second application, what we are doing some substitution. The substitution will be like this. be like this. Here OCH3. Thereby you will get double bond. Here we are having OCH3. For your convenience, I am writing this one in this way. OCH3. This is subjected to Algar Flynn Oyamada reaction. You will come up with what? This is one of the important example in case of the examinations. Here OCH3. It's very simple. If you remember the first example, based on the first example, you can easily identify the products in the second example or second application. This is all about Algar Flynn Oyamada reaction.